Hi, my name is Dear Tiagi, and in this video I'll be going over L'Hopital's rule. So to start, when do we use L'Hopital's rule? We use L'Hopital's rule when we're given a limit, like so. Let's say limit as x approaches a of f of x over g of x, and what we get as an output is an indeterminate. So in the AP Calculus BC exam, there are two types of indeterminates that you need to know. There is 0 over 0, or infinity over infinity. So if we get one of these two indeterminate values, what we have is an issue. We don't know if the limit exists or the limit doesn't exist. And because it's an indeterminate, we still have to see if there's other ways we can try to solve it and see if the limit exists. So one technique to find a limit if we're given one of these indeterminates forms is to use L'Hopital's rule. So L'Hopital's rule states that the limit as x approaches a of f of x, g of x, over g of x equals the limit as x approaches a of the derivative of f of x divided by the derivative of g of x. And that's the L'Hopital's rule. And remember, this only works if we have an indeterminate like 0 over 0 or infinity over infinity, which are the only types of indeterminates you need to know for the AP Calculus BC exam. There are more, but these are the only ones that they'll be testing you on. Great, so that's L'Hopital's rule. Let's try out a few examples just to see if we understand it. Let's say we're given the problem, the limit as x approaches -1 of 5x to the fourth plus x minus 4 over 2x cubed plus 5x plus 7. So whenever we see a limit problem, we should always try plugging in first. So if we plug in -1, we get 5 minus 1 minus 4, which is 0. And we get -2 minus 5 plus 7, which is also 0. So we get the indeterminate 0 over 0. So in this case, let's try using L'Hopital's rule to solve the problem. So we take the derivative of the top. So the derivative of the top is 20x cubed plus 1. The derivative of the bottom is 6x squared plus 5. Now we can try plugging it in again. We see that we get -20 plus 1 over 6 plus 5, which comes out to be -19 over 11. And that's our final answer. So the process we did here, we first plugged it in. We saw it was 0 over 0. Because it's indeterminate, what we can do is we can use L'Hopital's rule. Next, let's try out another problem. Let's say we're given the problem limit as x approaches infinity of e to the x over x squared. So in this case, if you know the acronym Tom Likes Pizza Every Friday Night, which states that the fastest growing functions are n to the n functions, fastest, and the slowest growing functions are trig functions. So trig, slowest, then logarithmic, polynomial, exponential, factorial, and n to the n is the fastest. So if you know this rule, you can see that exponential is higher than polynomial, so it's going to go to infinity because e to the x is going faster than x squared. But let's say you didn't know that. Let's say you wanted to solve this problem without knowing this fact. So we could try plugging in infinity. What we'll get is the limit as x approaches infinity of e to the x is infinity, and the limit as x approaches infinity of x squared is also infinity. So we get an indeterminate form. Okay, so let's try using L'Hopital's rule. Let's say we take the derivative of the top. So the derivative of e to the x is e to the x. The derivative of the bottom, x squared, is 2x. And we do the same thing again. So we take the limit as x approaches infinity of e to the x, we get infinity again. And the bottom limit as x approaches infinity of 2 of the x, we get infinity again. Okay, so L'Hopital's rule didn't work for the first time, but the important thing is we can keep doing L'Hopital's rule over and over. And the reason why is because, just think about it, what we just did is we used this function to make another derivative, f of x over g of x. Now, based on this equation, what we can say is, let's pretend this is f of x, g of x. We can now repeat this process over and over. So basically, L'Hopital's rule says that any, so limit as x approaches a of this function f of x over g of x is equal to any derivative of x over any derivative of g. Okay, again, because it's circular, that's why. So take the derivative again, we get a limit as x approaches infinity of e to the x over 2. And now finally, the limit as x approaches infinity of e to the x is infinity. And the limit as x approaches infinity of 2 is just 2. Infinity over 2 is just infinity. And that's our final answer. Okay, so let's just do one more problem, and then that should be enough for understanding this rule. Let's say we have the problem limit as x approaches infinity of e to the x minus 1 over cosine of x minus 1. So in this case, we plug in, or sorry, not to infinity, to, let's say, 0. So plug it in, we get e to the 0, which is 1, minus 0, minus 1, which is 1. Cosine of 0 is 1, minus 1, so 0 over 0. So we do L'Hopital's rule, we get a limit as x approaches 0 of e to the x minus 1 over negative sine of x. So we get e to the 0, which is 1 minus 1, over sine of x is, sine of 0 is 0, so negative 0, so 0 over 0 is just 0. So we have to take L'Hopital's rule again. We take it again, we get limit as x approaches 0 of e to the x over negative cosine of x. Now what we get is we get e to the 0, which is 1, over cosine of 0, negative 1. And we get negative 1 as our final answer, which is also the limit for that, based on L'Hopital's rule. So again, just to reiterate, the process is we plug in numbers. If we get indeterminate, like 0 over 0, or infinity over infinity, we can keep taking derivatives of the top and bottom using L'Hopital's rule until we get a value. And that's how we use L'Hopital's rule. Thank you guys all for watching, and I'll see you guys all tomorrow. Bye.